This video will focus on building the major surfaces of the Gain bottle, but before we do that, we're going to take a look at some of the details of the front layout sketch. We notice here where the right-hand surface arc curves into the handle underside, we have a spline which is actually crossing over itself in this area. Solidworks does not allow splines to cross over themselves, so this is actually drawn as two splines. One here and one here, which meet at this dividing line. This dividing line will be used to divide the right-hand surface from the handle undersurface and also control a plane for drawing cross-sectional sketches for building this boundary and this boundary. A similar dividing line divides the top cap area from the handle upper surface. Here we see the dividing line, which will also be used to control a plane. Going down to the bottom area of the handle, we see that these arcs are intentionally crossing over the right-hand surface curve so that when we build the handle surfaces, it will intentionally intersect with the right surface, which we will then later on trim this excess away. Now we'll take a look at this difficult intersection area. This is a single arc, which is the lower edge of the cap, blends down to be the center edge of the handle, and meeting up to that is this edge which divides the front surface from the right surface. They meet right at this point. We also have this edge which divides the left surface from the front surface, and I've purposely not made them come together at the same point. I've also drawn this arc so that it goes tangent to this spline. In order to do that, because this spline is continuous all the way through, I had to draw a separate line meeting at this point, made the line tangent to the arc, and then finally made this spline tangent to the line. The reason I wanted this tangent in this area is so that when this surface is filled in, I have a nice smooth arc through here that will be created when the boundary surface is built, starting at this edge and moving onward in this direction. This is a lot of splines meeting together and influencing each other, so if you're having trouble adjusting your splines without messing up the other ones, temporarily fix the splines that you are not adjusting and then only leave the spline that you are adjusting unfixed. Then when you're happy with everything, you can unfix the splines that you temporarily fixed. You might notice some errors temporarily when you're doing this, but don't worry about it because you'll be unfixing the splines later. To give an example, if I move this spline around, or say this spline around, you notice that a lot of things are going out of whack. So if I temporarily fix this one and this one, when I want to adjust this one, chances are things will stay more stable. The rest of the layouts are fairly straightforward. I have a layout on a right-hand plane that passes through the center of the screw top cap and has some relations going back to the front layout. As you can see, this line piercing to this arc here, and this line piercing to this point here. The front surface is nothing but a sweep using this curve and this curve. These curves are intentionally stretched out a little bit beyond their original limits in order to overbuild the surface so that it will trim back neatly. The left-hand surface is simply a boundary surface which copies a curve from the front layout and a curve from the bottom layout and is attached to this edge of the front surface. To keep it under control, I had to add an extra cross-sectional curve here and cross-sectional curve here, otherwise it had a strange bulge occurring in this area. This upper edge is a projected sketch which we'll discuss in the next video.